Okay, this is section 4.2, and we're going to be solving quadratic equations by graphing. And yesterday, all we did was we graphed quadratic equations without our calculator. We did that by using a table. Today, we're going to solve by graphing, and we're actually going to use our calculator. So before we start, though, we already know that the standard form of a quadratic equation is ax squared plus bx plus c equals 0. Okay, and where a cannot be equal 0. Otherwise, it'd be a linear equation. Okay, so we're going to talk about some basic vocabulary words today. The solutions of a quadratic equation are called the roots of the equation. And one method for finding the roots of equation is to find the zeros of the related quadratic function. So anytime I'm solving a quadratic equation, our answer are called the roots of that equation. And to find the roots, they're also called the zeros of the related quadratic function. Okay, so the zeros of a function are the x-intercepts of its graph. Okay, so I graphed y equals x squared minus x minus 6. This is the graph. Its x-intercepts, if you'll notice, it crosses the x-axis here, and it crosses the x-axis here. Those are the roots, or the zeros, of this equation. So if I had to solve this, x is equal to 3, and x is equal to negative 2. Okay, that means, and this is the equation of the graph that I graph. That's the equation that goes with this graph. When I plug 3 in, 3 squared minus 3 minus 6, that's 9 minus 3 minus 6. All of that should equal 0, and it does. I could plug in negative 2 and get the same thing. So 3 and negative 2, when I plug them into this equation, gives me a true equation. So the roots, or the zeros, are where my graph intercepts the x-axis. Okay, now notice we don't care anything about the y-axis, we're just talking about the x-axis. So example 1 says solve x squared minus 3x minus 4 equals 0 by graphing. All right, so we're going to graph this in our calculator. Y equals, I guess I need to turn it on. So y equals x squared. Okay, if I can get it. Is it not going to square? Okay, hang on a second. I don't know. My calculator's not working for some reason. Let me see if I can bring it back up. Okay. So turn it on. All right, y equals x squared minus 3x minus 4. So the first thing, when we solve by graphing, our quadratic equation has to be set equal to 0. And this one already was. Okay, I'm going to put that in my y equals. We're going to graph that in our standard viewing window. So our window should be negative 10 to 10 on our x and y axis. And then we're going to graph. Okay, now sometimes you can tell very easily where it crosses the x-axis. It crosses here at negative 1, and it crosses here at 4. So x equals negative 1, and x equals 4. Okay, I'm going to bring my calculator back up. Now, sometimes it doesn't cross at nice, neat points like that. And I'm going to show you the calculator steps here in just a minute to show you what to do when it doesn't cross at nice, neat whole numbers. Okay, so that first of all, that's easy. It crosses at negative 1 and 4, so that's my answer. Okay, now what does that mean? I could plug each one of these in, and when I simplify it, I get 0. Okay, let's do another one. Example 2. All right, I'm going to solve 14 minus x squared equals negative 6x plus 23 by graphing. The first thing we have to do is we have to set this thing equal to 0. Okay, so let's move these two things over to the right-hand side. So I have 0 equals negative 14 plus x squared minus 6x plus 23. And then let's write this in standard form, ax squared plus bx plus c. Okay, so we want our x squared term first. So I have x squared minus 6x, and then I'm going to combine my negative 14 with my positive 23. So that's going to be 9. So once you set it equal to 0 and you have it in standard form, now we can graph it and see where it crosses the x-axis. So y equals x squared minus 6x plus 9. Graph. Okay, so now this one, can you tell it's a little bit hard to see where it crosses? Okay, so I'm going to change my window a little bit. Okay, so I'm going to hit my window button. I'm going to change my x min to -5 and my x min to +5. And let's go ahead and change my y min to -5 and my y max to +5. And let's just see if that helps a little bit. And graph. Okay, so it looks like it crosses at 3. All right, now here's the thing. What if we can't tell for sure? Here are the steps that you're going to follow. We're going to hit second trace for calc. We're finding the zeros of our function, so we're going to choose number 2 for 0. Now, if you look at down here, your calculator is going to start asking you questions. It's going to say left bound. So what they want you to do is they want you to either move your cursor, and I don't even see my cursor, or type in a number to the left of where it crosses. Well, I know a number to the left of that is going to be -1. So I'm just going to type it in since I can't find my cursor. Then it's going to ask you another question, right bound. Now they want you to type in a number to the right of where you think it crosses. So I'm going to type in 5. Now they want you to guess where it crosses. I think it crosses at 3, but we're not for sure. So I'm going to type in 3. And then it tells you you have a 0 when x equals 3. Okay, so, and in this case, I only have one answer. It crosses one time or touches one time at x equals 3. So x equals 3 is my answer. Okay, example 3. Solve x squared minus 6x plus 4 by graphing. It's already in standard form, so we're good. I'm going to put that in my y equals x squared minus 6x, whoops, plus 4. Graph. Now, I probably need to change my viewing window back to the standard viewing window because I'm not seeing this other point. So the shortcut to change it to a standard viewing window is to hit zoom 6. All right. So now if you'll look, these do not cross right at nice, neat whole numbers. So I'm going to have to find each point. So we're going to follow our calculator steps. I'm going to hit second trace for calc, number 2 for 0. Now let's find this point first. So see my cursor? It's going to say left bound. That means go to the left of where it crosses. Well, my cursor is already there, so I'm going to press enter. Then it says right bound, so I'm going to move my cursor to the right of where it crosses. So do you see where it moved? I'm going to press enter. And then it says guess. I'm going to put my cursor about where it crosses and press enter. I have a 0 when x is 0.76393202. Okay, we're always going to go 3 decimal places. So my first x is 0.763. You can round or you don't have to. 0.763. There's my first 0, or x-intercept. Okay, now let's find our other one. We're going to go back to our graph, And we do the exact same steps. Second, trace. Number 2 for 0. This time I'm finding this one, so I'm going to move my cursor over a little bit. It says left bound. Okay, so I'm to the left of where it crosses. I'm going to press enter. Right bound. Enter. Guess. Enter. So I have another 0 at 5.236. 5.236. And those are my two answers. Okay, example 4. Use a quadratic equation to find the two real numbers with a sum of 15 and a product of 63. Okay. Okay, use a quadratic equation to find the two real numbers with a sum of 15 and a product of 63. All right, so we don't know what these two numbers are, so I'm going to call one of them x. I'm going to say that's my first number. Now, if I know that these two numbers have to add up to be 15, does it make sense that my second number would be 15 minus x? Okay, because when I add these two things together, they have to equal 15. Okay, just like if this one was 10, then to get my other number, and if I know they add up to be 15, it would be 15 minus 10. My second number would be 5. Okay, so here are my two numbers. And it says they have a sum of 15 and a product. Product means multiply. So I'm going to multiply these two numbers together, and that should equal 63. Okay, so first let's distribute my x. So I have 15x minus x squared equals 63. Now this becomes a quadratic equation, and we know that we can solve quadratic equations by graphing. Before I can graph it, it needs to be put in standard form. So let's take all this over to the right-hand side. Okay, so I have 0 equals positive x squared, because I moved it over, minus 15x, because I moved it over, plus 63. So now I need to graph this to find my zeros. And my zeros are the solution to the equation. All right, so y equals x squared minus 15x plus 63. Now, I don't know, my viewing windows, the standard viewing window, I might need to change this. We don't know yet. Okay, so see, it's way up here. All right, now tell me, if this, okay, is my equation is way up there. Let's look at it again. And we could change the window if we needed to. Okay, but there's my parabola. Is it ever going to cross my x-axis? No, this is my vertex right here. That's my smallest point. So it's never going to get any closer than that to the x-axis. So this is no solution. That means there's not any numbers who add up to 15 and then when I multiply them together give me 63. It's not possible. So on this one, it's no solution. Okay, last example. Use the table to determine the location of the zeros of the quadratic function. All right, so this time they didn't give me an equation to graph. I could graph these points and see where they cross the x-axis. And some of you may want to do that. When I'm given a table like this, okay, let's look. Our y values, well, let's just go ahead and graph these. Okay, I have the graph or the point negative 1, 9. So negative 1, 9. 0, 2. 1, negative 3. 2, negative 6. 3, negative 7. 4, negative 6. And 5, negative 3. So you see, here's my graph. okay? Now, I'm going to have to estimate, okay? And how I find the location of the zeros is where I would have a 0 for my y values. I'm looking for zeros here. Well, I don't have any, okay? So I need to see where did it go from negative to positive or positive to negative. Or somewhere between 0 and 1, it crosses the x-axis, okay? And I know that because here's 0 to 1, and it went from a positive to a negative number. So I'm going to say between 0 and 1. And then do you see where my next point would be? If I went one more, if I went to 6, okay, do you see my y values? It's -3, -6, -7, then -6, -3. What do you think this next one is going to be? Because remember, if I have a point on one side, I'm also going to have that point on the other side. So if I have 6, if I went one more, following the pattern, -3, -6, here's my vertex, -6, -3, do you see that my next number should be 2? So I'm also going to have a 0 between -3 and, oh, not -3, I'm going to use my x values, 5 and 6. Okay, so sometimes instead of giving you an equation or a picture of the graph, they're going to give you a picture of the table, and you have to guess where the zeros are located. You're always looking on your y values where a 0 is. If a 0 is not listed, you're going to look and find out where my y values went from negative to positive or from positive to negative. And your answer will always be your x values. So between 0 and 1, and between 5 and 6. Okay? I believe your assignment is at the top of your paper, and you're going to need your graphing calculator for it.